Hello there, and then welcome to another brand new video. Now in this video we'll still solve questions on all that we have done so far. There are more questions to be solved. It is important we do so that at least we would test our understanding of whatever we have learned, right? So let's quickly go straight into it. If this is your first time on this channel, this is Help Beyond Numbers, where we learn maths the very easy way. If you have any requests, you can always let me know at the comment section, and then I would address that for you by the help of God. Now, question 4 says, let X denote the number of patients who attend a clinic in 1 hour. Suppose X has the following probability distribution. So there's our probability distribution here. State whether X is discrete or continuous. In our tutorial lessons, we learned that for discrete random variables, they have distinct values. Whereas for continuous random values, they take values within a range. If you look at X over here, X has value, or X, our random variable, has values of 0, 1, 2, and 3. These are distinct value. Hence, X, random variable X, is what? A discrete one. It's a discrete variable. Okay, now let's go to 2. So A was quite very simple. 2 says, find the value of C. You have to find the value of C. How do we get the value of C? There were 2 conditions for a probability mass function to be, for any function to be a probability mass function. The first one was that the probability of each random variable should be greater than or equal to 0. As we can see here, that satisfies. And the second one was that the summation of all these probabilities should be equal to 1. So that is the idea we'll be using to solve B, right? So the condition says that the summation of from I equals 1 to n should be equal to 1. And if you look at our function over here, that is, we don't, okay, so these are our probabilities, right? We weren't given the function, but then this is actually a table. So we also learned that there are 2 ways of representing the probability distribution. One being in a table form, and then one using the probability mass function. So for this we have over here, it's in the table form. So what it means is the probability of X equals 1, using the values we have here, plus the probability of the random variable X equals, it actually starts from 0. So let me clean this here, and then we start all over from 0. So for random variable X equals 0, random variable X equals 1, and then random variable X equals 2, then plus our random variable X equals what? 3. If we sum all these up, we are supposed to get the value 1. Easy. So we now do our substitution. From our table, we're told that the probability distribution, the probability of a random variable being 0 was 0.1. Easy. And then that of it being 1 was 0.5. That of 2 was C. And then that of 3 is also a 0.1. And we are saying they should all be equal to 1. Easy. So now we are doing our addition. 0.1 plus 0.5 gives us 0.6. 0.6 plus 0.1 should give us a 0.7 plus C equals 1. So making C the subject, we have C equals 1, then minus 0.3. And that should give us C being equal to, minus 0.7 rather. So that should give us C being equal to what? A 0.3. Right, so that becomes the value of C as we were told to what? Solve for. Right, so that is B for you. That is B. Then now let's go to C. C says find the probability that at least 2 patients will attend the clinic in a given hour. The probability that at least 2 patients. At least 2 patients here means at least. So the lowest value should be 2 patients. So this is under at least 2 patients. The probability that 2 patients and then 3 patients as well. Right? The understanding is very important. So at least 2 patients here means 1, 2 patients, and then 2, 3 patients. Per the random variables we have here, it is just 2 and 3 that satisfies that. Right? So our C, which is probability of at least 2 patients. So that is going to be probability of X, probability of our X being, let's say, greater than or equal to 2. That is at least 2 patients, right? So probability that our random variable X is greater than or equal to 2 would then mean we need probability of our random variable X being equal to 2, and then probability of our random variable X being equal to 3, right? So from our table, the probability that our random variable X will be equal to 3 is equal to a C, and the C was 0.3 plus our random variable X being equal to 3 from the table is also 0.1. So we add these two, 0.3 plus 0.1 giving us a 0.4. You see, so the probability that at least 2 patients will visit the hospital, the clinic, within an hour is what? 0.4. Right? So that solves B. Then now let's go to the next one, which is the last one. We want the probability that our random variable P is what? Our random variable X is less than or equal to 2.5. Less than or equal to 2.5. So once again, we refer to our table. And in our table, which of the random variables satisfies it being less than or equal to 2.5? So less than or equal to 2.5, we'll definitely start from 2.5. Because 2.5 itself satisfies this or equal to here. 1 is also less than, and then we have 0 also being less than. So it means we are going to add these probability distributions to give us what we are looking for over here. Right? So let's quickly go into it. Okay, so we want the probability that our random variable X is less than or equal to 2.5. I hope I am right. Yeah, 2.5. So this simply means we need a probability that our random variable X is equal to 0 plus the probability that our random variable X is equal to 1. Then plus the probability that our random variable X is also equal to 2. You see, and from the table, from our table, let's go back to the table. 0 was 0.1, 1 was 0.5, and then our C corresponds to the 2. So we have 0.1 plus 0.5, and then the C, which we calculated as what? 0.3. Adding them all, we have 0.1 plus 0.5 giving us 0.6. Then 0.6 plus 0.3, that gives us 0.9. You see, so hence the probability that our random variable X is less than or equal to 2.5 will become what? 0.9. So that answers all the questions we have for this session. And if you found this video helpful, you can choose to subscribe and then share as well. If you have any issue of concern or any mathematical topic you would want us or you would want me to make a tutorial video on it, you can always let me know in the comment section. Thank you very much, and then have a blessed day.